My name is Falki Jain from Vidyanand Online, and if you are new to this channel, then consider subscribing right away. In this section, we are going to study about one of the most important chemical, which is bleaching powder. So bleaching powder is something which is not new for us, right? We use this bleaching powder in textile industry and also in laundry. So whenever you have stain on your white color shirt, the first thing your mother does is she puts that white color stained shirt into the bleaching powder in order to remove the stain. So we are going to study because of which property do we use bleaching powder in laundry. Also, there are many more interesting things we are going to study about bleaching powder. So let's start with that.
Calcium oxychloride is actually the chemical name for bleaching powder. Yeah, and it is also called chloride of lime. So, in the last session we studied about sodium hydroxide, right? We studied about caustic soda, and this caustic soda was prepared from NaCl, which was common salt. Okay, now this bleaching powder is also prepared from NaCl but indirectly, right? So when we prepared sodium hydroxide, we found that chlorine was prepared as the byproduct, right? Now this chlorine is actually a gas, and we know that it is very difficult to store gas and then utilize it. So in order to solve this problem, we have bleaching powder. So bleaching powder is actually an arrangement in order to store chlorine. Now let us see how we are going to prepare this bleaching powder. So in order to prepare the bleaching powder, what we are going to use is, we are going to use dry slaked lime. I hope you remember what is dry slaked lime, right? So slaked lime is obtained from lime, right? This is not lemon, this is lime. So the formula for lime is CaO, calcium oxide, which is also called quick lime. Now why quick? Because it actually reacts very quickly with water in order to form slaked lime. Slaked lime is CaOH2. It is highly exothermic process, and that is why we have to be very cautious. Now this slaked lime is actually wet, but we require dry slaked lime. Now what we are going to do is, we have to dry it so as to remove water from it, and thus we will get the dry slaked lime. Now the chlorine gas is allowed to pass through this dry slaked lime in order to get the bleaching powder. Let us see how. So this is the Heisenklaver plant, which is used in order to produce the bleaching powder. So here if you see, there is shaft and these are blades. So from the one end, the slaked lime is dropped into this plant, and from the other end, the chlorine is passed. Now I am very much sure you must be thinking that why from these two different parts are these two reactants added. Actually what do we want is, we want that slaked lime should completely react with chlorine. In that way, slaked lime is slowly dropped into the first cylinder, then through the blades it is sent to the second cylinder, and so on. In the similar way, the chlorine gas is passed from the last cylinder to the above cylinders. In that way, we ensure that slaked lime is completely mixed with the chlorine gas in order to produce bleaching powder, right? In that process, some waste gases are also produced, which is exited out from this point, right? So what reaction can we see here? We see here that chlorine reacts with calcium hydroxide, which is a dry slaked lime, in order to produce what? In order to produce bleaching powder, which is CaOCl2, along with the formation of water. Now let me tell you, this is not the actual composition of bleaching powder. The actual composition of bleaching powder is quite complex. So in order to simplify its representation, we actually make use of this formula. So this is bleaching powder, right? Now we are going to understand the properties of this bleaching powder. Now the first property is that it is a yellowish white powder with strong smell of chlorine. Now why it happens is, calcium oxychloride is CaOCl2, which is bleaching powder, and it slowly reacts with carbon dioxide present in the air, right? So this carbon dioxide slowly decomposes calcium oxychloride, which is bleaching powder, in order to give calcium carbonate, which is CaCO3, along with the liberation of chlorine gas. That is why bleaching powder gives a very strong smell of chlorine. Next, it is soluble in cold water. So bleaching powder is actually soluble in cold water. It means it gets completely dissolved in cold water. However, there is a very small portion of lime which is actually left behind whenever you dissolve bleaching powder in water. Next, it is very important. It reacts with dilute acid in order to give chlorine gas. Actually, the strength of bleaching powder is actually dependent upon the amount of chlorine which is there in that bleaching powder. Okay, what do I mean by this? So every bleaching powder have different percentage of chlorine in it, and this chlorine is actually called available chlorine. Okay, now greater the amount of this available chlorine, more superior will be the bleaching powder. So a good sample of bleaching powder actually consists of 38 to 40% of chlorine inside it. So whenever you need to obtain the pure chlorine from the bleaching powder, you need to make use of dilute acid. You can make use of dilute sulfuric acid or a dilute hydrochloric acid. For example, you have calcium oxychloride, which is bleaching powder, reacting with dilute sulfuric acid. Now what you will get in product? You will get calcium sulfate, CaSO4, along with chlorine gas, and this chlorine gas is actually called available chlorine in this bleaching powder, and the formation of water. Similarly, if we want to react bleaching powder with dilute hydrochloric acid. Now this is also dilute, right? So what we will get in product? We will get calcium chloride along with chlorine and water. In order to balance it, we will put 2 here. Okay. So whenever you need to extract the pure chlorine from bleaching powder, you will always make use of dilute acids. Now next is the most important property of bleaching powder, which actually is the essence of bleaching powder, right? It is what? It is that bleaching powder is a strong oxidizing agent. So why oxidizing agent? It means that it can easily add oxygen to any of the molecule or any of the atom of the substance to which it is react. Now again, the reason for its oxidizing agent is chlorine. So here chlorine actually acts as a very strong oxidizing agent. Now let me tell you how. So calcium oxychloride, which is bleaching powder, is actually used with the help of water, right? So when these two are mixed together, that is how we are going to use it. Okay, when they are mixed together, they will give you calcium hydroxide, which is flake lime, along with the formation of chlorine. Okay, now this chlorine again reacts with water in order to form HCl, which is hydrochloric acid, and HClO, which is hypochlorous acid. Hypochlorous acid. Okay. Now this hypochlorous acid is very unstable. So what happens is it again dissociates in order to form HCl and nascent oxygen. So whenever you have oxygen without 2 as a subscript, it means you have a single atom of oxygen, then that is called nascent oxygen. And this nascent oxygen is very strong oxidizing agent. So this is how from chlorine you obtain nascent oxygen, and this nascent oxygen reacts with the atom of the cloth or anything which you want to bleach in order to oxidize it, right? Now let us see the uses of bleaching powder. So one of the most important use of bleaching powder is that it is used to bleach cotton and linen clothes in textile industry, and also in bleaching the wood pulp in paper industry, right? So what is the literal meaning of bleach? Bleach means to decolorize something, right? Or to remove color from something, or to make it lighter than what it was. Now the bleaching action of bleaching powder is because of the chlorine present in it. This chlorine acts as an oxidizing agent, therefore it oxidizes the substance into which it is put. Let us take this example in which you have 3 cotton dupatta, right? So they were not naturally dark yellow, orange or yellow in color. They were initially white in color. So they were dyed in order to get these colors. So the yellow color dye molecules must have stuck on this dupatta, because of which it is now yellow in color. Now what happens is, if you put this into the bleaching powder solution, then you will get nascent oxygen, the way I told you before, and this nascent oxygen actually oxidizes these dyed molecules in order to have much lighter shade of it, right? It is also used in the paper industry. So this is a picture of wood pulp from which the paper is obtained. Now the paper which we use is actually white in color. Now the question arises that how come this wood pulp, which is brown in color, is converted to white color? Now this is because of the bleaching action of the bleaching powder. Now the next is, it is used as a disinfectant. So what is disinfectant? It means that it makes the water fit for drinking. Now we know that in bleaching powder we actually have chlorine gas once you dissolve bleaching powder in water, right? Now this chlorine gas is very toxic for the microorganisms that lives in a water. Okay, so what happens is, when you treat the drinking water with the bleaching powder, the chlorine gas is released, and this chlorine gas kills the microorganism present in the water and thus making the water fit for drinking. For the similar reason, if we talk about swimming pool, then swimming pool is also treated with bleaching powder, and that is why it smells of chlorine. The last use is, it is used as an oxidizing agent in many chemical industries. We have already discussed about this. So bleaching powder is a very good oxidizing agent, and that is why many chemical industry use bleaching powder as an oxidizing agent. Okay. So with this we have completed the topic bleaching powder. In the next session we are going to study about baking soda. Till then, bye bye and take care of yourself.